Welcome back to College Algebra Videos. We will be solving systems of equations again, but this time I'm not going to tell you which way to solve them. In fact, the whole point of this video is for us to see how I think about solving systems and hopefully to encourage you to think in your own way, discover the ways that are faster for you to solve these systems. Again, so I'm going to focus on how I think about them and how I figure out which ones I should solve first. So let's go ahead and, there's another thing that we're going to do. So again, the first thing is we want to know which one is the most effective method, but we're focusing on what I think the most effective. It should really be what you think is the most effective method. And the second thing, we're going to identify these three terms: consistent, inconsistent, and dependent. And I'll define them when we get to examples that are like them, okay, so that you'll get it then when it's actually the most useful. So let's go ahead and the first one. So here is this system. Solve the system using any method. Identify the system as consistent, inconsistent, or dependent. Well, as soon as I see these equations solved, well, I got three ways of doing this, right? I can either graph, I can either use substitution, or I can use elimination. But I look at this and I go, wow, someone already went to all the work and solved both equations for me. And I don't need they solve them. I know that here the slope is 1/3, and I know here the y-intercept is 0, -2. And then in this equation, the slope is still 1/3, and the y-intercept is 0, 4. Oh, that's just begging me to graph. And so I don't have graph paper, but this is an easy thing to graph, so I'm going to go ahead and graph them anyway. Please excuse the fact that this is not going to be the best graph. But for example, the first line, so equation 1, I go to -2, which is maybe down here, and I go up 1 and over 3, 1, 2, 3. And then I go up 1 and over 3 again. And again, graph paper is always better when you're doing solving by graphing, but there's my first line. And then I look at the second line, and this one starts at 4, 1, 2, 3, 4, and it also goes up 1 and over 3, and then up another 1 and over 3 again. And then as I graph this, especially if you're using graph paper, you start thinking, or you start remembering, wait a minute, I remember that someone said once that if the slopes are the same, the lines are parallel. Lines are parallel. So remember that when we solve the equations, wherever they met is the solution, but these lines are parallel. They're never going to touch. So since lines don't cross, there is no solution. There is no solution. And so what we call this, if you remember, this is inconsistent. And so when you do this, make sure you say, oh, it's on your final anyway. You want to say no solution, and you want to say inconsistent if I ask you for that. Really quick, in case you were wondering, how would I solve this any other way? Let me show you. Let me use substitution actually. Just so you can see something I want you to see something algebraically in case this happens to you on your homework. Since I can replace this y with this expression right here. And so what I would get is I would get on one side on the left, 1/3 x plus 4 is equal to 1/3 x minus 2. And notice that if I subtract 1/3 x from both sides, these cancel, and I'm left with 4 equals -2. And so if you had done this by substitution instead, you would get something that looks really strange. And again, though, your conclusion should be the same. No solution. And if you say no solution, that means inconsistent. So either way, whether you graph these or solve these by substitution, then you're going to be fine. Now, the reason I graph them, so again, because they were already solved, I thought they were very easy to graph. Number 2, substitution was going to have fractions, and maybe I don't want to deal with fractions. And then to do the elimination, I would have to rewrite everything so that it looks the way I told you. There has to be an x and a y and then some equal sign. So that was just a little bit more work. So this is why I thought that graphing, to me, was the best method for this example. All right, let's look at it. Here, our second example. As I see this, I need to figure out which method to use first. And again, I'm so amazed because someone has already taken the time to solve for y. Y is already solved for. There's nothing for me to do. And the second one, though, is not solved. So I go, I don't know if I want to solve it. That's a little bit extra work. So my thinking is, well, why don't I just use substitution? That's exactly what I'm thinking here. So in my mind, use substitution. And what I'd like to do is take this 2x plus 5 and put it in here for this y. And so what I'll get is I'll get 4x minus 2 times something equals negative 10, but that something is this 2x plus 5. And then when I do all the work, I get 4x, distribute this, I get minus 4x, distribute there, so I get negative 10 equals negative 10. And so notice I get these cancel, and I get negative 10 equals negative 10, which is true. It's definitely true. And this, remember, this means an infinite number of solutions, infinite number of solutions. Now again, once that happens, for this particular case, when you have an infinite number of solutions, this means the system is dependent. And so that's the word that we're going to use when you get this case. Now there's a couple of ways to get this case. One of them is by getting something that's true all the time. But the second way, again, just in case you decide to use a different method, I want you to look at equation 2 a little bit more carefully. So equation 2, I have 4x minus 2y equals negative 10. If I decided to solve for y, because I want a graph, so minus 4x. So this is maybe, let me maybe say graphing method, just in case I feel like graphing. If I do that, then this cancels, and I'm left with negative 2y equals negative 4x minus 10. And then if I divide by negative 2, everything by negative 2, I'll get that y equals 2x plus 5. But look, that is the same equation as this one. Exactly the same. And if I graph them, they'd be exactly the same graph. So same graph, or same equation, if you ever get this situation where you get the same graph or the same equation, then it's going to be dependent. It will always be dependent. Okay, so just in case you know. So again, just to recap, I think substitution would be nice because somebody has already solved it for me. So I think, why not use the work that somebody else has done? I get something that's two things are true, so that means dependent, and there's another way to do it by graphing if you so choose. Again, it's up to you. Choose the method that works the best for you and that's fastest. Most effective, as I say. All right, here, I look at this one and I go, oh, do I really want to solve for x and get a third, or get a fifth, or get a half, or get a fifth? I don't know. Seems like a lot of work. And so in this case, I think elimination is my best option. And the way I'm gonna do this is I'm gonna multiply. Oh, I don't have to multiply anything. I look at negative 5y, I look at positive 5y, and I go, this is already set up so nicely. I don't have to multiply, I just have to add. And in fact, 3x plus 2x is 5x. This is 0, and then I get negative 15. And so I get that x is equal to negative 3. And then I'm going to show you something else that's pretty cool. This is a different way of using elimination. I'm going to multiply this equation, multiply by 2. And so that's equation 1. So I'm going to rewrite it over here, equation 1. If I multiply everything by 2, I get 2x minus 10y equals 2. And the second equation, I'm going to multiply by negative 3. So negative 3 times 2 is negative 6x. So I'm going to rewrite it over here. This is equation 2. And negative 3 times 5 is negative 15y. Actually, I said by negative 3, right? I made a slight mistake. This should be 6x, right? Because 2 times 3 is 6, 2 times negative 5, let me see, 2 times 3 is 6, 2 times negative 5 is negative 10, 2 times 1 is 2, so that's good. All right, and then negative 3 times 2 is 6, negative 3 times positive 5 is negative 15, y, and then negative 3 times negative 16 is 48 plus 48. And what happens here is this time these cancel, and I'm left with negative 25y equals 50. And if I divide both sides by negative 25, I get that y equals 2. And so my answer is, the answer here is x equals negative 3, y equals 2. And we found a solution, and so when we find a solution, this means consistent. And there we go. So this is consistent. Now, I didn't have to do the second step. This part right here, I didn't have to do that way. I could have plugged in the 3 and for the x over here and then solve. That would have worked just fine. I just want to show you that sometimes you can use elimination twice. And this one was set up for elimination, and that's why I used elimination. I thought it was the most effective way to do this. And again, if there is a solution, it is consistent. All right? Good luck with the homework.